Start it again, beta. Some network problem came, so I just started again. Okay. Yes, beta. Some network problem came, so started again. Okay. Now look here. So what we were talking about, base metals. So base metals is exactly doing what, beta? Base metals are doing what, beta? Base metals. Hi Bhavya. Hi Tanisha. Correct. Okay. Correct, beta. Now network problem was there. So suddenly it got stuck. So I rejoined it. Whenever stucking means I will be again rejoining you all. Okay. Now look here, beta. So copper is considered a base metal as it oxidizes relatively easily through, although it does not react with HCl. Okay, it is commonly used in opposition to noble metals. So now, beta, we need to understand that. But copper also is oxidizing. Copper is easily oxidizing, but it will not react with HCl. That reactivity series is there, now. In that we will be talking about that. Okay, so now noble metals are metals that are resistant to corrosion, understood, so are and or oxidation, unlike most base metals, understood. So what is the difference between noble metal and base metals? Noble metals will not corrode, but base metals will corrode. That is the difference. So base metals are those metals which will be corroding. They are very reactive to oxygen, but noble metals are not reactive to oxygen. Noble metals are not reactive to oxygen, but base metals are reactive to oxygen, beta. So noble metals are not reactive to oxygen, but base metals are reactive to oxygen. So who will do corrosion? Base metal or noble metal? Very good. So corrosion will be done by base metal, not by noble metals, not by noble metals. Understood? So now we will go to next one. So noble metals, which are the noble metals? You might be seeing the ornaments are made with gold, platinum, silver. So beta, these ornaments which are made with gold, platinum, silver, all of them are exactly what, beta? Noble metals. What they are? Noble metals. Bhavya, understood? What they are, beta? Noble metals. Why? Because they are exactly doing what, beta? They are non-corrosive, understood, and they will not oxidize easily. Absolutely correct, three of you. Shanvi, where Shanvi went? You inform Shanvi to rejoin again, beta. Anjali, rejoin, beta. I don't have any contact with this girl. Otherwise, I could have allowed her to join again. Now look here, beta. We will go for the next one. Non-metals. Now we will be talking about non-metals, beta. So in non-metal category, let's talk about the non-metal content. So non-metals are the name suggestions opposite to metal. Now beta, what are the properties of non-metal? So most of the, you need to understand one very important thing. Non-metals are not solid. Metals were mostly solid. Now what about non-metals, beta? They're either gases or solid at room temperature. But most of the non-metals are what, beta? Most of the non-metals are gases. Most of the non-metals are gases. We talked about carbon, sulfur, chlorine, fluorine, understood not? So they were exactly considered nitrogen, oxygen. So they were what, beta? Yes, absolutely correct, Aranisha. They are exactly considered as what, beta? They are gases. Understood? So they are either gases or solid. So we know iodine. Iodine is exactly what? Solid. Solid and liquid, it will be there. Got it? But mostly they are gases. Surface, they are vary in color, with generally dull surface. Are they having a shining surface? No, they are not having a shining surface. They have what type of surface, beta? Dull surface. They have what type surface? Dull surface. And diamond crystal of iodine have bright lusters. Conduction, mostly poor conductor of heat and electricity. Mostly poor conductor of heat and electricity. Understood? Mostly poor conductor of heat and electricity. Conduction we have talked about. Now beta, you need to understand allotropes of carbon. Okay, carbon is a non-metal. Listen very carefully and respond, beta. Carbon is a non-metal. Now, allotropes of carbon means different forms of carbon are there, like graphite, diamond, understood, Buckminster furan. So there are different type of carbon. Now understand what's up, beta, in class. So we will talk like class only. I'm in class 9th, beta. Students are learning right now. So whatever doubts are there, you can ask. I will clarify your doubts. Now look here, beta. Understand this one nicely. So if somebody will be asking you about allotropes of carbon, then you will say that carbon is exactly what? One of the unique element of periodic table. Though carbon is present in very less amount, that carbon is present in the living creatures in the most vibrant form. Okay, now we are talking about carbon allotropes. So there are two allotropes of carbon. No, there are three. We will be talking about allotropes further. But we have to understand one thing, that diamond and graphite are the allotropic form of carbon. Understood? So where diamond is totally different and graphite is totally different because of the presence of free electron and non-free electron. Diamond do not have any free electron. It is an allotrope of carbon, and beta, when it is an allotrope of carbon, what it is doing, beta? It is the hardest substance, and you know what? It is because of its non having free electron, it is bad conductor of heat and electricity. And graphite is having free electrons. It is exactly having van der Waal contents. I will discuss that one afterwards. In class 10th only I am explaining those things. So weak van der Waal force of attraction is there, and because of that, beta, what is exactly doing is, please, Ritik Rider, avoid this type. Beta, whatever is there, you talk to me, but don't respond to the student. It's not good. Okay. Now look here, beta. So you need to understand one thing, that when we are talking about diamond, diamond is hardest, graphite is different. It is not hard. Okay. And it is exactly opposite to that of diamond because of presence of free electron. Diamond can not conduct, diamond is not having free electrons, so it cannot conduct electricity, but graphite is having free electrons, and because of that it can conduct electricity. Understood or not? So this is exactly the features, this is exactly the properties of the true allotropes of carbon. So when we are talking about the physical nature of non-metals, first thing what we learned is non-metals are liquid, gases and solid. Where metal we have seen, most of the metals were solid, only one exception was there, and that was mercury. Understood? After that we talked about surface. Metals have a shining surface, but non-metals have a dull surface, but exceptions are there. So diamond is there, and crystals of iodine, they have bright shining surface. They were the exceptions. So diamond is a form of carbon. So only I explained this much. Understood? So that you will not be saying that, hey auntie, diamond is not present in periodic table, but you are explaining diamond. Beta, yes, beta. Is this from NCRT? Yes. So from NCRT content only, we have made that parts and we are teaching. So right now, class 9th, grade 9 classes are going on, and in that is matter around us is pure. In that explanation I am giving, and in that explanation, beta, I am explaining about metals and non-metals. Understood? So I hope you might have understood, beta. So here, what we have discussed, we discussed that ki diamond is allotrope of carbon. Carbon is a non-metal. Understood? And diamond are totally different from this part because it is exactly having a shiny surface. Understood? Conduction, are they good conductor of electricity? Non-metals are no. But only exception is graphite. Graphite is not in the periodic table because graphite is a type of carbon. Though carbon is having exactly allotropes, the graphite is one of the allotrope of carbon, and graphite is having free electrons. Because of the presence of free electron in the structure, beta, they are good conductor of electricity. Usually non-metals are good conductor of electricity or not? Non-metals are good conductor of electricity or not? Answer is no. Non-metals are not good conductor of electricity. But beta, what we have learned here is that the allotrope of carbon is graphite. Graphite is having what electrons? Free electrons. And because of the free electrons, they can conduct electricity. Unnati, nice to see you back, beta. Today you did not responded. Now, conduction, mostly poor current conductor of heat and electricity, but exception is graphite. Next, quite soft, but exception is diamond. Okay, beta. Diamond is what, beta? Diamond is what? Allotrope of carbon. Diamond is what? Allotrope of carbon. Malleable, non-malleable, and non-ductile. Non-malleable and non-ductile. Means we cannot be. How can you beat gases, yaar, and make into thin sheet? Possible? No. How can you beat liquid and make into thin sheet? No, na. Solid items are there, and they for what? Thank you, Niti. Ha, beta. Oh, just now you joined. Now look here, beta. I thought since beginning you did not respond. Now one time also I did not saw your name. Usually I'm having a habit of seeing your name. So today you did not appeared. So only I asked. Now look here, beta. So we learned one thing that okay, fine. They are non-malleable, non-ductile. Sonorous also not there. Understood or not? But they are brittle. What they are, beta? Brittle. Brittle means what? Totally brittle. Exactly. The brittleness is exactly one of the property of non-metals. Understood. So now we are going to talk about not sonorous. They have low melting and boiling point. Next is reactivity. They generally form acidic or neutral oxide without oxygen. So now last previous part itself I have discussed now. I told one thing, and that one thing was very important. In that part I have discussed one very important thing. Do you remember this part? I discussed that metal react with oxygen. What it is making? Metallic oxide. But that metallic oxide is acidic or basic? Metallic oxide is acidic or basic? Metallic oxide, that metallic oxide is acidic or basic, beta? That metallic oxide is basic in nature. Now non-metal react with oxygen? Acidic oxide. Absolutely correct. So they are making, yes, metals are making basic oxide, non-metal acidic oxide. Super, bingo. Now we are going to study the next part. So basic oxide. Now we'll go for the next one, reactivity. They generally form acid or neutral oxide with oxygen. That's what we were discussing. So now metalloids. Metalloids are those which is lying between metals and non-metals. Which is lying between what, beta? Metals and non-metals. There are few elements which show some properties of metals and others shows properties of non-metal. So their properties lies between metals and non-metals. Okay, so they look like metal but they are brittle like non-metal. So they are looking like metal, they have shining surface, they have hardness, but their properties are like brittleness is like non-metal. So that means what? They possess the property of both metals and non-metals. And when the element which possess the property of both metals and non-metal, it will be considered as what? Metalloid. It will be considered as what? Metalloid. It will be considered as what, beta? Metalloid. He was talking about what, beta? Boron. Boron. Most of the time he was talking about boron. So boron, silicon, germanium, arsenic, antimony, tellurium, and that is polonium. They are what, beta? They are metalloids. What they are? Metalloids. They are what? They are metalloids. Okay, because they possess the property between metals and non-metal. So 7 metalloids are there in the periodic table. Group 13, 14, 15, 16 and 17. They form zigzag step line periodic table. So this is exactly, I am going to draw this and I'm going to explain you. So zigzag property, what is like that? So now look here, in the periodic table, if you will be seeing, the periodic table will be like this and this. In this part, the zigzag section will be there. Here, they will be exactly considered as what? Metalloids. They will be exactly considered as what, beta? They are exactly considering as metalloid. I hope you might have understood here, beta. So they will be what? Metalloids. Got it? So they will be what? Metalloids. Absolutely correct, beta. So here, boron, silicon, germanium, arsenic, antimony, tellurium, and polonium are the metalloids. So let's have a difference. Who is solid? Metal. Exception? Mercury. Here, who is there either solid or gases, but bromine is liquid at ordinary temperature. So these are the difference between metal and non-metal. Luster, who is having lusters? So metals are having luster, but one example is there, which is exactly we can polish it and they will have shining surface. But here non-metals are dull, except which one? Iodine has lustrous appearance. Understood? Next, about melting point and boiling point. Metals are having high melting point and boiling point, but non-metals are having low melting point and boiling point. Metals have high density, non-metals have low density, but except one thing, that is diamond. Diamond is the allotropic form of carbon, so its density is different. Ductility, metals are ductile, understood? Non-metals are non-ductile. Now malleability, metals are generally malleable, non-metals are non-malleable, they are brittle. Conduction, metals are good conductor of electricity, but non-metals are bad conductor of electricity. Next, hardness, metals are hard, and but potassium and sodium, they are not hard, that's the difference. And your non-metals are generally soft, except which one, beta? Graphite, understood or not? So non-metals are soft except diamond. Graphite is also soft only. Okay. Now sonority, we can make noise with that, but non-metals are non-sonorous. Now we are going to talk next is compound of or chemical compounds. So now beta, we are going to now form compounds. Okay. So now in compound formation, I hope everybody understood this differences. Everyone, come on, tell me, did you understood today's class how to respond to these sections? I hope everybody understood this one now about metals and non-metals. Now we are going to talk about compound formation. How to make a compound first, like water molecule. So when we are talking about molecule, means what, beta? One and many will make molecule. So if one I am taking, it is a compound. When combination of this will be more will be there, then it will be exactly called as molecule. I will explain about the unit part and the total sections. But here, beta, you understand one thing. In next class, I will be teaching some very important things. So periodic table, a pure substance containing two or more elements which are combined together in a fixed proportion by mass. That is exactly, see, a pure substance containing two or more elements which are combined together with fixed proportion by mass. So every time compound will be connected, means a compound I am taking, that compounds will have two or more elements. Now beta, sometimes the compound formation means two or more elements will be there, and what will be there, beta? They will be combined together in a fixed proportion. They will be combined together in a fixed proportion. This is the most important point. They can be combined together in what, beta? Fixed proportion. They are combined together in a fixed proportion by mass. They can be combined together in a fixed proportion by mass. So now beta, here one most important thing is fixed proportion consisting of two element, hydrogen and oxygen. We'll take about water molecule. What is the mass of hydrogen? 1. What is the mass of oxygen? 8. So what is the ratio? 1:8. What is the ratio, beta? 1:8. So water may be obtained from number of sources such as rain, river, sea, well, lake, but in pure form or any source, the two elements are present in same fixed ratio. So it is not important that water you are bringing from which section. 1:, what is the ratio of by mass? 1:8. 1:8. 1:8. I hope you might have understood here. So that means to make a compound or chemical compound, we need the elements in fixed proportion, and then a specific elements will be joined together to make the compound. Okay. So now we will be talking about types of compound. Compounds are generally divided into two types: inorganic compound and organic compound. So we will be discussing this in next class. Okay. Inorganic compound and organic compound. In next class, we are going to study this part. Some internet beta, some glitch is there. So only problem is coming. Okay. Bye everyone.